Welcome everyone to the webinar, How to Develop a Carbon Credit Project for Your College or University. Thank you for joining us today. My name is Ruby Woodside, and this webinar is brought to you by Second Nature in partnership with SCS Global Services and Ball State University. The webinar will be recorded, and the recording and the slides will be sent to all registrants in the days following this webinar. There will also be a Q&A session at the end, and you can submit questions for the Q&A at any time using the questions function on your GoToWebinar panel. Next slide. So for the agenda today, first I'll give a brief introduction to the Climate Leadership Network, and more specifically how schools in the network can utilize carbon offsets as part of their climate action plans. Then we will hear from SCS, who will go into a bit more depth on the process of third-party validation and verification. And finally, we'll hear from Ball State University, a school that has been developing and selling carbon offsets for a few years now. And then at the end, we'll have some time for questions. Next slide. So first of all, I'd just like to spend a brief moment going over the climate leadership commitments for the schools that are unfamiliar with this. So Second Nature recently updated and relaunched these commitments. Schools that were previously signatories of the American College and University's President's Climate Commitment, known as the ACU PCC, are now signatories of the Carbon Commitment. So the Carbon Commitment focuses solely on mitigating climate change by reducing greenhouse gas emissions. Schools that are signatories of the Carbon Commitment, if they would like to also work on improving climate resilience along with mitigation, they now have the option of joining the Climate Commitment. So the Climate Commitment focuses on both improving climate resilience as well as mitigating carbon emissions and achieving carbon neutrality. So this is really the most holistic approach to climate change. And then we also have the option of the Resilience Commitment for new schools joining the network that would like to only focus on improving resilience. Next slide. So the three commitments, they do have a common framework. They're all made by presidents or chancellors on behalf of the institution, and they're designed to engage all students and other stakeholders. And then a large component of the climate and carbon commitments is a goal of carbon neutrality. So all institutions in the network are working towards carbon neutrality, most with goals of 2050 or sooner. And so today what we're going to talk about is how carbon credit sales can help schools reach this goal. And then I just also want to mention that the Sustainability Planning and Climate Action Guide is an online resource for implementing any of these commitments, and I encourage you to check it out. Next slide. So for some high-level context on carbon offsets, Second Nature recently released a new resource on our website that provides some guidance on using carbon offsets, and it discusses both purchasing and producing carbon offsets. So with producing offsets, which is what we're talking about today, there are a few options. We're now allowing a small portion of campus greenhouse gas emissions to be offset with innovative or peer-reviewed carbon credits. So these are smaller scale, often new types of projects that may not follow an approved methodology. And we have more details and guidelines on this online and in other presentations. But what we're going to talk about today are third-party certified carbon offsets. So these are credits that are externally verified by an approved organization. They follow an existing certified methodology, and then once they're verified, they can be sold on the voluntary carbon market to a buyer. Next slide. So just for a very brief overview of the steps involved in developing this type of project. So first of all, you would register the project on a carbon registry. Second Nature maintains an account on a carbon registry for VCS, the Verified Carbon Standard, which is the largest standard on the voluntary carbon market. Then you would have the project third-party validated to make sure it fulfills all the requirements of this methodology. Once the project is validated, you would monitor carbon reductions and then have those reductions verified, and that's again by a third party. And then finally, once you have certified emissions reductions, then you can sell those credits to a buyer. So that's a very brief overview, and SCS and Ball State will be talking in a bit more detail about some of these steps. Next slide. So before we get into the details, I just wanted to give a quick overview on how carbon credit sales can fit into a carbon neutral strategy. So one way to look at this is it's a way to finance deep carbon emissions cuts that will bring your school closer to its goals. So basically what you would do is you would use carbon credit sales to finance a larger scale project on campus that otherwise you may not have the capital to invest in. So for example, this could be a large-scale renewable energy project or energy conservation and efficiency project. So what you would do is you would sell the carbon credits for a few years to essentially pay back the initial debt, and then at some point you would stop selling the credits. So the graph that you see here, this is just a rough image of what your emissions profile would look like. So your emissions would decrease as you implement your project. However, during the time that you're selling credits, you cannot claim those reductions. So your reported inventory would remain at essentially the same level while you're selling credits. However, once you stop selling credits, your emissions will drop dramatically. So that's just this is just one example of a way to think about what we're talking about here. Next slide. And then another strategy is to use carbon credit sales to seed a green revolving fund, which can be used to finance other on-campus projects that lower emissions and reduce costs. So many schools already have green revolving funds, so this could be, the revenue from carbon credit sales could be added to an existing fund, or it could be used to start one if you don't already have a GRF. Next slide. So finally, many of you have probably at least heard of this program, but one way that schools and the Climate Leadership Network are currently developing and selling credits is through Second Nature's Carbon Credit and Purchasing Program, or C2P2. So this option uses an energy-based methodology through the Verified Carbon Standard. It's a potential option for schools that have already achieved high levels of emissions reductions in Scope 1 and Scope 2 emissions in recent years. And it's also possible for schools that have a high-performing LEED certified building on campus. So I'm not going to go into details on this today, but this chart just shows the level of average annual emissions reductions that are necessary to participate in this program. So if you're interested in learning more about C2P2 or participating in the program, please contact me. Next slide. Great. So now I'm going to pass it off to Blake Troxell from SCS Global Services. So Blake is a manager of SCS's Greenhouse Gas Verification Program. And with that, Blake, I'll leave it to you.
Thank you, Ruby. So I would like to take my time today to discuss the validation and verification process in general. I will cover the overall programmatic process as well as some of the specific aspects of validation and verification. I will also briefly touch on some generic verification timelines and a few broad characteristics of the carbon market in general. Next slide, please. Thank you. So SCS is an independent third-party certification organization. We specialize in auditing, testing services, and standards development. Our greenhouse gas verification program was established in 2008, and to date the program has verified emissions from a wide range of industries, including forestry, manufacturing, transportation, and energy, totaling more than 50 million tons of CO2e. SCS is also accredited to ISO 14065 for greenhouse gas validation and verification by the American National Standards Institute. This accreditation allows us to conduct carbon offset and carbon footprint verifications for various carbon programs, including the Verified Carbon Standard, or the VCS, which we will be discussing specifically today. At SCS, we have experience working through this process with universities and other organizations and can help facilitate the validation and verification process with you. Next. So before we get to the VCS, there are a few different types of validation and verification services that SCS is able to provide. In a project's planning phase, we're able to provide a pre-assessment or gap analysis, which doesn't result in tradable credits, but is more of an informational exercise that is conducted before the required steps of validation and verification occur. Validation of the project design is a required step under most carbon programs, as well as the verification of the actual emission reductions that occurred, which is the step that results in the generation of tradable offset credits. And finally, we are also accredited to perform greenhouse gas inventory verifications under a variety of carbon programs, so we can verify your carbon footprint to help you prove your carbon emission reductions over time. Next. Now, the VCS can be thought of as a carbon program, a carbon scheme, or a carbon offset registry. And really, all of these terms are essentially synonymous in the carbon industry. The circular diagram below illustrates the four key components of the VCS program. There are the VCS standards, there is independent auditing, accounting methodologies, and the registry system. So the VCS standard establishes the core rules and requirements that must be met for any project, program, or activity to be certified under the VCS framework. The VCS standards set out higher level programmatic requirements that include detailed rules and procedures that must be followed by any given project. Independent auditing encompasses the VCS validation and verification phases to ensure that projects, programs, and activities meet the required VCS standard. This aspect is conducted by validation and verification bodies such as SCS. The individual accounting methods allow for the determination of baselines, in other words, what would have happened in the absence of the project activity, and set out specific parameters for measuring, accounting, and monitoring the impacts of any given offset project. These are already developed and approved by VCS, and the project teams simply need to apply them to their given offset project. And finally, the VCS registry displays the performance of projects to allow tracking of results, or in some cases, tracking of tradable credits. Now, the registry is the final programmatic component of any typical standards framework and is essential to functioning certification markets. The VCS manages this registry and provides these services to all of its VCS account holders. Now, as the VCS program applies to the campus clean energy and energy efficiency project type, the diagram on the right side of the screen indicates the hierarchy of the different documents involved in the VCS program. At the highest level, at the top, is the VCS parent standard document and the VCS program guide. These documents must be coupled with an approved accounting methodology. And in this case, that is the VM0025 methodology. This methodology is a little unique because it must also be used with one or both of the VCS modules listed below. Therefore, any given university participating in an offset credit generation project using this methodology will need to meet all of the applicable requirements set out in each of these documents listed here. Next. Now, one question I hear quite often is, what is the difference between validation and verification? So, according to the VCS, validation is the independent assessment of a project by a validation and verification body, an organization like SCS, that determines whether the project complies with the VCS rules. Again, this process evaluates your specific project design to ensure that it meets all of the eligibility criteria and is most often more qualitative in nature than the verification phase. Additionally, the validation phase must occur before the verification phase. However, it can also be conducted concurrently, which is often the most cost-effective option for project developers. Now, verification, on the other hand, is a more quantitative assessment by a validation and verification body. The assessment really dives into the greenhouse gas emissions data that is a result of the project during a specific monitoring period conducted in accordance with the VCS rules. Now, a verification body cannot verify future credits, and during the entire period under assessment, the project must have complied with all of the VCS rules and requirements, which we covered in the previous slide. Now, in the most common scenario, a project will initiate an annual verification of their offset credits generated during the previous calendar year. Sometimes project teams will choose January 1st to December 31st, or maybe it follows a financial calendar. But that reporting period can be dictated by the project team. Next. Now, if we dive a little bit deeper into the requirements of project validation, a validation verification body must assess the following issues that are listed on the left side of your screen here in the slide. First is conformance to the VCS rules. conformance to the applied methodology, including the procedure for the demonstration of additionality, and also the likelihood that the methods and procedures set out in the project description will generate verifiable greenhouse gas data when the project is finally implemented. Now, some of the general criteria assessed during the validation phase are listed on the right side of the screen here. We have to look at the project description, the project start date, its location, who owns the project activities, what is the project boundary, the baseline scenario is very important, as well as the issue of additionality. And then we also want to look at the quantification procedures that you will be carrying out in the future, as well as the monitoring methodology that will be carried out in the future as well. Next. So, on the other hand, during verification, a validation verification body must assess the following listed on the left side of your screen here on this slide. The first is the extent to which the methods and procedures have been implemented in accordance with the design that has been previously validated. So this includes ensuring conformance with the validated monitoring plan as well. And the extent to which the greenhouse gas emissions reductions and removals, so those are the credits that you generate, are accurate. So in other words, are your carbon calculations correct? And more specifically, on the right side of your screen here, this also includes continued evaluation of conformance with the VCS requirements, evaluation of the greenhouse gas data that is provided and generated, assessment of the completeness and accuracy of the project documentation, recalculation of your emissions data, and the preparation and submission of the verification documentation to the VCS. Now, this will include a validation and verification report, as well as a verification statement. Next. Now, determining a timeline for all of these activities is not necessarily cut and dry. The timeline is highly dependent upon communication and transparency between the verification body and the project team. However, we usually try to plan for anywhere between 8 to 12 weeks for completion, with the understanding that it could happen more quickly or it could be drawn out a little longer than anticipated. So this generic schedule highlights some of the more important milestones that we cover during any given verification process. We begin with a kickoff meeting. Some projects have an office meeting that can be coupled with a field visit. We then perform the document and data review, which takes a large portion of our effort in the verification and validation process. That overlaps most often with the findings process, where we may identify issues and we bring those to your attention. You have the opportunity to correct those issues and report back to us for review. Once all the findings have been closed on our end, then we can begin the report writing process. Once the report is complete, that has to go through an internal review process, and upon completion of that process, then we can begin submitting the documentation to VCS for their internal review. After the VCS approves the project, then they will issue the offset credits in the project's name. Next. So if you are interested in learning more about the carbon market in general and the supply and demand of offset credits, I would recommend that you take a look at the Ecosystem Marketplace website and read their annual carbon report. They provide some very good information about how the market operates in general and where we all fit within the carbon industry. In the schematic on the right-hand side of the screen, the project developer would be you, the university or college. Your credits would then have to go through third-party verification, so that is the phase that involves us at SCS, before the credits could be sold to a wholesaler, retailer, or an end buyer. Or on the other hand, the credits could simply be retired internally within your own institution in order to offset your organizational carbon footprints, in turn reducing the absolute emissions emitted by your university over a given year. Next. And finally, I wanted to quickly identify a few characteristics of validation and verification bodies that you should be considering when choosing a verification body for your project. First, credibility. Is the verification body accredited to the appropriate schemes and programs that you need? expertise. Do the individual auditors have the necessary qualifications to conduct the assessment? Experience. Has the verification body conducted verifications of your project type before? And finally, value. Does the verification provide added value and assurance to your organization's internal sustainability and climate goals? So as a validation and verification body, we here at SCS are able to help you work through this process to generate carbon offsets in order to meet your climate goals. And with that, I will hand it over to Dr. Koester of Ball State University. Thank you.
Thanks very much. This is Bob Hester. I'm happy to be here with you today, and I'm going to give you a quick review of the Ball State experience as we initiated the work to develop the methodologies for use by colleges and universities, and then more recently how we've been working with Second Nature as our broker, essentially, for transacting our carbon reductions in the market. Next slide. We were an early signatory to the ACU PCC back in the day, and subsequently have signed on as a climate leadership commitment university. So this is just a quick history. This is how we got into this activity, because we did make the commitment to become climate neutral. Next slide. We as a result, had to prepare a climate action plan, which we did, as well as conducting our first greenhouse gas inventory. Our climate action plan has 9 steps, which includes transparency and monitoring of everything we do so that all stakeholders and constituents can be apprised of how we're working toward climate neutral conditions. We have 5 categories of energy conservation activity, which includes our large geothermal district heating and cooling facility that we installed and has been online now for a short time. We are working in the area of information technology, campus transportation, building conservation, and the adoption of policies that affect occupant behavior primarily. And then we anticipate longer term that we'll engage in electrical production both on campus and off campus, because we're located in a part of the country that's primarily a brown power segment of the e-grid, and so most of the electrical power that we import to run the campus is coming from coal-fired generating facilities in the Midwest. Next slide. We filed our climate action plan back in 2008. We updated it about 5 years later in 2013, so if you go online and download this thing, you'll see these red annotations throughout. But the reason to show this slide, which is quite fuzzy, is just to indicate the stair-step patternings that you see on the right. These are our ways of graphing our discussion about goals and objectives for carbon reduction. We wound up working in 5-year blocks, so each histogram element there is a 5-year window left to right, in order to begin to understand how we could integrate carbon reduction planning with the university's traditional 5-year strategic planning. Next slide. We brought that then into a unified presentation that you see here. In 2006, we signed the PCC, and within 2 years, we had completed our first greenhouse gas inventory, and at that point, we were emitting something around 192,000 metric tons annually. We subsequently got into this effort with the creation of these methodologies and the participation in the voluntary carbon market, and realized that in fact in establishing the boundary, which was referred to earlier, the boundary of the campus, we had to remove in the yellow sector here the amount of energy and emissions associated with our supply of electricity and heating and cooling to a regional hospital which is adjacent to the campus. So really our campus began its accounting at the 154,000 mark once we removed the hospital from our operations. So the boundary of the campus per se is the 154,000 metric tons. Since that time, we've begun the installation of the geothermal project. It's up and running. All 47 buildings on campus now are being cooled with that technology. We have about 33 buildings online for the heating, and we will get the rest online in the coming year. And when it's all done, all 7 million square feet of the campus will be heated and cooled with the geothermal district scale system. But even in the short time that we've been operating, we've already gotten enormous reductions in our greenhouse gas emissions because, in large part, the application of this geothermal heating and cooling system. Next slide. The district scale system is located in two places, the north and south half of campus. This is the North Energy Station. It has two huge heat pump chillers inside of it. These are connected to a ground source network, and we either extract heat from the ground or put heat into the ground through exchange coils that are located every 15 feet on center. Next slide. The total scheme of the district scale system is shown in the campus map. We have the two borehole fields on the north, which are in the yellow areas here, 1,800 boreholes in that area. And the North District Energy Station that you just saw the photo of is shown there at the top. And then we have 1,800 boreholes on the south and a South District Energy Station. And then everything is looped and networked with horizontal piping around the campus, some of which is only just this past summer been completed on the south half of the campus. And then at the time this particular graphic was made, all the green buildings are the ones that are connected at that time to the system. We now have many more that are hooked on. But basically we have 2 energy stations, 3,600 boreholes. All 47 buildings are connected. This has been about a 5 to 7 year project. It'll be finished next year. It costs $83 million, which is roughly $25 million more than it would have cost to install a straight-up boiler replacement for the heat plant. As a result of this technology, we're saving $2 million a year in operational costs. We don't buy coal anymore, and we are using less electricity, actually. And so we're getting about a 12.5-year payback, or roughly 8% return on that incremental cost of investment. Next slide. So we've adjusted the stair-step reductions based on the impact that this technology has had on our campus operations. And just this past March, our interim president approved moving our target neutral date from 2050 to 2030. So what you see here are these 5-year increments of reductions, and the reds and triangles represent 5-year blocks of goal for knocking some amount of emissions out of our profile. The biggest piece, of course, is at the end, but I'll explain that in a minute. But these are the targets that we have, and we're on track to be able to meet this goal. Next slide. We worked with Climate Neutral Business Network, Bonneville Environmental Foundation, Chevrolet to help create and test out this methodology for colleges and universities, and went through the processes that were just described, both validating the methodology and then verifying its use in specific carbon reductions for our campus. And so now if you go on the VCS project database, you can find us there in Indiana, and you can download all of our documentation on what we've done so far. We also continue reporting through Second Nature our emissions reductions, but we also annotate in them the fact that now that we're starting to transact these reductions, we don't claim them against our goal of 0. For the moment, we're holding that claim off until we get to that point in the next 14 years. Next slide. It was mentioned also that there's a distinction between validation and verification. Once you get your methodology validated, and we've gone through that hurdle now, you have a 10-year window in which to use the method to achieve annual transactions in the carbon market. So it's on an annual cycle that you do verification once you've completed the initial validation of the method. Now the method is very easy to use because in fact it's a template, and this is a fuzzy screen image, but you can download these documents off the VCS website. You have a project description document which is used to set up the validation process, and there are 2 pathways that universities can follow to participate in this opportunity. One is to do a campus-wide intervention in carbon reduction and to claim the campus-wide performance as a thing that will be tracked as a way to generate emissions that can be transacted in the market. Or if you want to do a building by building LEED certified type of reduction, you can do it that way. In either case, you pick a template. In this case, we picked the campus-wide template, filled in all the appropriate information, checked a series of boxes, which you can't really read there on the right, but basically those boxes are talking to all the kinds of things that most campuses do on an annual cycle to manage their energy use. Behavior change and campaign activities and communications, cogeneration or fuel switching, lighting retrofits, on-site renewable use, boiler retrofits and cooling and heating upgrades, building system retro-commissioning, weatherization improvements to building shells, windows and such, LEED certification of new buildings or building renovation, and then occasionally the use of innovative strategies. So it's really just a checkbox arrangement when you use this template to make your project description, and you either say yes, no, we're doing these things, and then that starts to tabulate and accumulate in the document that you ultimately send in for validation. Next slide. Then you have to issue a monitoring report, which is really a statement of how internally you're going to manage the flow of information so that your facilities folks are using their meter readings and they're gathering data on their expenses for utilities and they're recording that in a consistent way. You're bringing that into the system here for presentation and documentation. And the buildup over this 10-year window that you see on the right for annual reductions and net available carbon units that can be transacted in the voluntary carbon market. And again, this is a template. You mostly just fill things in. You'll see in this slide gray boxes for the coming years, which we haven't loaded in yet, but we will be as we move forward. Next slide. The core of all of this reporting, which is used both in recording for Second Nature and the Climate Leadership Commitment, what used to be the ACU PCC Commitment, is the same as the tool used for the validation and verification work. It's the Clean Air Cool Planet Calculator, which was originated at the University of New Hampshire and is a rather robust spreadsheet. This is the cover page of that spreadsheet. It's a 5-column map of places you can go in the spreadsheet structure to load in information or to read out information. You start typically on the top left with your input window. Next slide. And when you hit that green box, you'll get a spread that looks like this, and you'll load in information about your institutional characteristics, what your budget is, how many students you have, and so forth. You'll pick on the top red arrow there what e-grid region you're within for your electricity sourcing. You'll load in your numbers in kilowatt hours that you consume every year. So this is a very straightforward thing to do. It's a robust spreadsheet. It's a little daunting when you first look at it, but in fact it's easy to use. And as long as you have the raw data from your facilities personnel, you can load it in pretty quickly. Next slide. You then go to another button in the map, which is the PCC Reporting Output. Next slide. And you'll get all the numbers you loaded in translated into an actual metric tons of carbon dioxide equivalent that were attributable to your Scope 1, your Scope 2, and your Scope 3 emissions categories. So you'll see here our Scope 1 emissions dropped dramatically from 2011 to 2014. Our Scope 2 emissions stayed fairly flat. I can report now that we're starting to see a drop in our electricity consumption. So on the more recent reports, it's getting better. And then Scope 3 is largely placeholder information that we have at the moment for our air travel and our solid waste stream. We don't document anything on commuting at this point. And then there are other things for research universities that might have biogenic emissions or other kinds of emissions associated with their research activity. And then on the far right, you see renewable energy credits. We did, in fact, as a campus, on 2 occasions, purchase renewable energy credits as an element of a submission of one of our newer buildings for LEED certification. So we actually list those as a counter credit, if you will. In other words, because we bought those, we can't use that percent or that amount of carbon reduction, because in fact we've already made a commitment to a third party for the renewable energy enterprise that they were engaged in. But those were for specific years, so as the years roll on, you start seeing those are no longer present. Next slide. When you use the methodology, which was developed with partnership with Climate Neutral Business Network, you again use a spreadsheet. This is another robust spreadsheet, and this is a snapshot out of it. Again, it's a fill-in-the-blank check sheet, and everything is color-coded, so you know that wherever there's a green zone, you're loading in information. Everything else is internal to the operations of the spreadsheet, and all numbers are calculated automatically. However, the reason to show this slide is to point out how you set up the base year from which you're going to evaluate all of your carbon reductions for transaction in the marketplace. In this case, we picked a 5-year window, 2007 through 11, to track the square footage of the campus, the stationary 1 and stationary 2 emissions, and from that arrived at an average base condition, which became defined as year 0. We then take the first year of our geothermal and other campus-wide conservation activities and compare those against that project year 0, and that's what gets used in this spreadsheet tool, the CNBN methodology tool, to start to arrive at the actual reportable numbers in both the validation and verification activity. Next slide. Part of the methodology is, again, very straightforward. You go into this spreadsheet and you check off what applies. So we're a doctoral institution, so we checked off that appropriate box. That means that for Scope 1 emissions, we have to have at least a 5.68% reduction from year 0 to year 1. It turned out our reduction was 19.2%, so we were well above the required minimum. If, on the other hand, you were going to use this tool to track your upstream emissions management, which would be your electricity, that would be the second column here, which is not in yellow. I didn't highlight that one, but you would check the appropriate box and enter in your data, and it would automatically calculate what your campus average percent reduction is, and you would determine whether you pass that test for qualification for the use of the methodology. Next slide. Now that we've done this and we've cycled it for several years, we're in a position to really start taking aggressive action and to make use of the capital that we're generating from the transaction in the voluntary carbon market to help drive our reductions more quickly and more deeply, which was the graph that you saw at the front when Ruby was going through that. For that period of time, we're reporting no net emissions for the purposes of climate leadership reporting, but we are reporting those emissions for purposes of transaction in the market. But given that, these are the kinds of things now that we're aggressively tackling on campus: reducing emissions through demand-side management, continuing lighting retrofit and other technology swap-outs, beginning to focus on behavior change with certain incentivized activities. We now have dorm competitions in fall and spring to see which of the residence halls can hold their energy use down the most, and they get prizes and a trophy. We also have some future capital projects that are coming online, and we've targeted them for net zero performance for both new building and renovation construction. Next slide. We've also focused initially on self-generation, so we've begun to look at the possibility of a solar farm. We're keeping an eye on wind machine technology. We're talking about possible building integrated photovoltaics on one of the newer buildings that's coming online. We're talking about net positive as the goal for all new building construction. Right now our standing policy has been LEED Silver, but we're moving in this direction toward net positive electrical production. The CHP, combined heat and power, is a small scale thing that we're likely to put in place in the next several years, because we do still have to produce a small amount of steam, not only for selling to the hospital, but also to maintain some of our laboratory equipment. Next slide. This is a mapping we've done preliminarily on a piece of land that we have north of campus, and we can generate at current efficiency technology almost half, a little less than half of our annual electrical production that we would require to run the campus. So this is the first effort at scoping the idea of using some of the carbon capital to underwrite some of this larger investment. Next slide. We've had students involved in scoping photovoltaic integration with our buildings. Next slide. Next slide. And we're looking at the 5-year window of time here where between now and 2020 we hope to do several different kinds of things, seeking capital appropriations, mounting capital campaigns, and so forth. So the marketing of the transactions in the carbon market have helped us to lay the platform for this work. Next slide. You can go to our BSU edu/sustainability webpage and learn more about what we've been up to. With that, I'll end my presentation, and I think we have time for questions and answers.
Great, thank you, Bob, and thank you, Blake, as well. So we have time for several question and answers here. So feel free to submit the questions that you have in your chat box. We've already gotten a few questions. So I will just start with this one, which is, what is the current average price for a carbon offset per metric ton? So in the voluntary carbon market, it's interesting. There's a very wide variation in the selling price of carbon offsets depending on the type of project it is. So right now, I believe that the average price across the market is around $3 or $4 per ton. However, what we found is that there is pretty high interest in the types of projects that we're talking about. These on-campus energy-based projects in the U.S., we found that we were able to sell the credits in more of a niche market. So we anticipate selling these, college and university-based credits for between $6 to $10 per ton. And then let's see, another question here. What kind of information and supporting data do you need from the schools in order to perform the validation and verification? Blake, would you like to answer that and speak to some of the data and information that you often request from schools?
Yeah, I can jump in here, and Robert might be able to help as well if I forget anything. But there's really a wide array of documents and data that we would request from a university during the validation and verification phases. For example, during the validation phase, we could be asking for title to land, or for example, to prove the right to initiate the project. We could be asking for background information on the project that was developed by a given university. Do you have a climate plan that you use to develop this program with? Let's say you were updating lights or updating weatherization, something like that. We're going to ask for receipts, that you actually purchased those materials or that you actually installed those materials. We want to see proof that that occurred. Robert also mentioned invoices, electricity invoices. It could be coal invoices if you're using a boiler. It could be natural gas invoices. So we really want to see that primary data going back to the actual activity that occurred.
And I can add that was pretty easy to gather because, of course, our business affairs and facilities folks do an excellent job of paying the bills and managing the budget. So it was not too hard for them to pull the data. The only tricky time we got into was when we were asking for real-time information in December, because normally the billing doesn't happen until January, so we were having to contact them at the close of the calendar year to get the current invoicing even before they would normally send the invoice. But that was the only wrinkle that we encountered. Everything else is a matter of record and it's easily pulled out of the files.
Great, thank you. Looks like we have a clarifying question here asking whether or not Ball State is currently selling carbon offsets to fund these initiatives, and if so, how does the school reduce its own emissions? So quick answer, and I'll give it to you, Bob, is that yes, Ball State is selling carbon credits, and then currently is not claiming those emissions reductions for the time being, and then in the future we'll see a large drop in emissions once the school stops selling credits. Is there anything else you want to add to that, Bob?
That's correct. Yeah. We everything is transparent. So when we submit our reports to Second Nature, there's a way in the Clean Air Cool Planet spreadsheet to document that a certain number of tons were transacted in the voluntary carbon market, and as a result, they don't count toward your goal of neutrality for that reporting year. So you actually enter the value as a negative value to counterset the reductions that actually show in the scope 1, 2, and 3 profile of the spreadsheet. So that's very matter of fact and easy to do. But as Ruby mentioned earlier on in the presentation, at some future date, as we get near 2030, we will have stopped transacting in the marketplace. And at that point, whatever our emissions level is, that will be our new reportable level. So we will have followed the curve that she showed in that one early graph.
Great. So we're getting a few questions about the costs involved with this. So I'm wondering if, Blake, could you speak to the typical cost for validation and verification?
Yeah. And the cost for any one given project is really dependent upon the size and complexity of the activity that is being carried out. So we do perform internal analysis every time we get an RFP or somebody comes to us with questions and has a potential project. We have a lot of scoping questions that we'll ask to try to figure out exactly how much effort it's going to take us to carry out the validation and verification. Some validations and verifications, for example, in the forestry sector, are on the very high end. Could be around $30,000, $40,000, depending on the size of the forestry project. There are some project types that are somewhere in the middle, around $10,000 to $15,000. But these project types, our experience with them has been a little bit lower than that. On average, around maybe $7,000, but it can be less than that once we get to know the project type, and let's say we do it for a couple of years, then the effort that we need to put into it is reduced, and then the cost can be reduced as well.
And I can add to that right now that we're budgeting about $1 a ton as a cost on our end, so that would be a worst case scenario, but that's a thing that can be built into the package of transactions. So anywhere from 40 cents to $1 a ton for the cost of everything is just something that comes off of the total sale. And Ruby talked to you about the range of possible transactions from $6 to $10 a ton. So it becomes a pretty manageable thing for a college or university to build us into that kind of budgeting.
And then one thing I want to clarify about the way Second Nature works with these projects. So there is no cost to the schools to engage with this process through Second Nature. How it works is that, so the schools do need to be a member of the Climate Leadership Network, so the president needs to have signed one of the climate leadership commitments. However, if schools wish to develop carbon credits and they're eligible following this methodology, then what we do is that Second Nature pays for the cost of validation and verification upfront, and then when there is a sale, we keep a portion of the sale price in order to recuperate those costs. So that's essentially how the this particular program works between Second Nature and the schools that we're working with.
And our experience now is that it's a quite fluid arrangement, and we've been working quite well through the C2P2 program, and everybody's got their feet on the ground, and so now it's almost becoming automated, and it's working quite nicely.
Great. And then we had some question about engagement. How were students engaged on campus? I know at Ball State that there were some student research opportunities. Could you mention that, Bob?
Yes, we got students involved in all kinds of ways. We've got on our geothermal project, we have students that are working, actually pursuing their graduate degrees in geology and other of the hard sciences, and they're actually monitoring the performance of the system in real time. So they've got, we installed temperature wells around the borehole fields so that we can go down and see what's going on in the ground with instruments. And we've got resistivity technologies that can be used to profile the makeup of the soil and the temperature profile. So we've been able to have a handful of students at the graduate level involved in that way on an annual cycle. We've got students that have been engaged in some of these lighting retrofit and building integrated photovoltaic examinations to see what would be the possibility of replacing a technology with a higher efficient technology, or what would be the benefit of landscaping the roof or the wall or the skin of a building with some high-grade photovoltaics. We've had students doing other forms of reporting on commuting and vehicle transportation fleet kinds of metrics. We've had some students that have been working on our food and dining service area to see what can be taken out of the waste stream, and we have eliminated all garbage disposals on campus, for example. We now do our composting with all of our food service areas. So students have been involved in all those things all along. We also have an immersive learning commitment at the institution, so it's possible for faculty and students to team up and build a project around one of these opportunities and do that in a semester or an academic year.
Great. So then we have another question. Are there other forms of verification validation for smaller scale projects that might not be able to afford the 30 to 40,000? So again, for these types of energy-based projects, typically Second Nature will pay the cost upfront. But that being said, the project does need to be at a size that it's economically feasible to do that, right? So that the initial cost will be recuperated by the sale. And so for smaller projects, at the beginning, I mentioned that we're now allowing and kind of exploring this idea of innovative and peer-reviewed offsets. And we do have more information about that on our website with the new carbon offset guidance. But the idea is that for some, very small local projects, it's just not worth it to go through this third-party certification process. And so there are some schools that are working, developing ways to do either, peer-reviewed verification or, other ways to kind of show robust emissions reductions without some of these costs. But again, that's for a much, much smaller scale of projects.
And I should clarify here that the $30,000 to $40,000 is not for this type of project. That was just an example of a forestry project, which is vastly different than this type of project. But on average, these types of projects, we've come to see them around the $7,000 mark on average, getting closer to $10,000 on the higher end, and then a little bit less than that on the lower end.
Right. Okay, so let's see. We had another question about whether or not you can use any verified emissions reporting tool for this methodology. So all the schools that we've worked with so far, they have used the campus carbon calculator that's run through University of New Hampshire. However, I don't believe that's required by the methodology. What is required is that schools are publicly reporting on their greenhouse gas emissions. So it's possible to use other ways to report and other carbon calculating tools to do so. And then, let's see, we had a question about administrative buy-in. So, Bob, I'm wondering if you could talk at all about how you were able to get buy-in from administration at Ball State.
Right. Well, part of the involvement on our part was to try to front end some of the work. So we treated this as a research opportunity. So we were able to advocate for administrative buy-in as a way of supporting not only the idea of bringing in capital, what's called carbon capital, to underwrite future projects through some form of a green fund. It would be a revolving fund. But we also argued the point that this was empowering faculty and students to engage in the actual trial and error application and development of the methodology so that it had a research function. And since and that was a very convincing argument up this chain of command and was well received. And since we got into this activity, we've had a number of papers and articles and chapters that have been written in books and in publications and in a lot of conference proceedings where this has been shared with the general public, including, of course, this webinar. So that's been a very positive dimension to the administration, seeing this as a valuable thing to do because it's ringing more bells than just a cash flow bell, if you will. We've gotten great cooperation from the business affairs folks and from the academic affairs side of working together, and it's been a very positive thing.
Great. So it looks like we have time for one more quick question. We have one for SCS. So how much of the project needs to be done before you can do validation and verification?
Yeah, that's a good question. As I mentioned, you could do them independently, validation first and then verification second. Validation is essentially assessing and evaluating your planned activities. So what you plan to carry out, what you plan to perform in the future. So that can happen early on in the process, and then verification has to occur after the credited activity has taken place. So you cannot verify future credits. You always have to verify past credits. And so in most cases, projects will elect to use a calendar year or a fiscal calendar year as that periodic monitoring report. However, as I mentioned earlier as well, you can carry out those two phases concurrently at the same time, but that would again have to happen at the end because verification has to occur after the fact. But you would then validate the project plan, the project design, your monitoring requirements, as well as verifying the greenhouse gas data, your calculations, and all the quantitative aspects at one point in time. So there are two options here. You could validate first and verify at the end of the first year, or you could wait until the end of the first year and you could validate and verify at the same time together.
And Ruby, this is Bob. I'd like to add one other thing, which is that the campus-wide methodology does not require that you install a geothermal project. In fact, all universities that are doing day-to-day conservation work can qualify for the use of that methodology. It's lighting retrofits, lighting upgrades, building shell retrofits, all the kind of conservation work that typically goes on can qualify. And one of the schools that participated in the early work, University of Illinois at Urbana-Champaign, generated considerable carbon capital, and it was all assignable to their ongoing conservation work. So that's a big factor in a performance-based evaluation system, which is what this is.
Yes, that's a good point. Thank you for adding that. So just for clarification, this particular methodology we're talking about, when we talk about the campus-wide module, that really includes any activities that you do on campus that are going to reduce your Scope 1 or Scope 2 greenhouse gas emissions. So it's very open-ended as far as what campuses can do to qualify for this particular methodology. And the schools that we've worked with have done a wide variety of different activities on campus. And if you're interested in more details on this methodology, we have a past webinar that's recorded, and then we're also happy to talk about that. So I got to wrap it up now. We're running out of time, but I just want to say thank you so much to Blake and Bob for your participation and your input on this webinar. As a reminder, we recorded the webinar today, and so this will be posted online, and we'll also be sending out the slides to participants and our contact information will be there, and so feel free to reach out to us if you have any further questions. Thanks a lot.
Thank you.